Okay, in all honesty, this is going to be the most underwhelming group problems because really all we're asking right now is for you to draw things, not to solve things, just to draw things. So what we have here is a 10 kilogram block and it's subjected to a force of 500 newtons. Okay, 500 newtons coming down here, which means we're going to have 400 newtons going in the horizontal and 300 newtons going straight down. Okay, didn't actually have to do that for this, but why not? Then we have a stiffness of 500 newtons per meter in my nice little spring. Now when S is equal to 0, the block is currently at rest and the spring is uncompressed, okay? And the contact surface is smooth, which means there's no friction. It says draw the free body diagram of the block. Well, we know initially there's no force pushing back, so all that force is going to be pushing to the right. And what you know, I'm giving you the answer. So what I should be doing is pausing and saying, hey, go try this problem on your own. Grab your rubber duck, grab your little traveling gnome, grab a friend, a parent, and do it together. Okay? Just draw the pictures, the free body diagram, and then the kinetic diagram. I don't like those kinetic diagrams, but at the very least it will get you thinking about what direction it should be going at the end. So with that being said, pause, come back in 3, 2, 1, and you're back. So we're going to do the exact same thing we did last time. So the first thing is we're going to say, okay, we'll have an inertial XY frame and it's going to be fixed to the ground. So right's positive and up is positive. Now we have a free body diagram of our block. Well, the spring is going to start pushing back on us the further we move. So this is an equation. Currently S is 0 because it's not moved at all. We have our 500 Newton force right here. We have the weight, which is equal to its mass times gravity. We have some normal force, which we don't know yet. Normal force, which we don't know yet. Now there's no frictional force, which would normally be shown something like this, because it said it was a smooth surface. A smooth surface. Now that's not too bad. And it makes sense to us as well, because if we forget any one of these forces, it would be unbalanced. For example, if I forget this force right here, well, I guess it technically could balance out then. That would be fine. But some of these forces I couldn't forget. Let's look at one. Like this one right here. If I forgot that force, there's a force pushing right and nothing pushing left. If I forget this force, there's forces pushing down, but no force pushing up. So you have to have all of them. You're going to see that you have to have something going in every single direction to maintain stability. So with that in mind, let's jump to the next slide and look at our handy dandy kinetic diagram. Actually, not next slide, just down here. Now, what is this? That's the mass, this is the acceleration, and it's pointing to the right because we have a force going to the right, and initially S is 0. So it's unbalanced to the right. Unbalanced to the right. So that's it. That is this problem. That is all the drawings. Free body diagrams, you need to master that. Kinetic diagrams, not quite as important. They're more of a way to check yourself, okay? They're a way to check yourself. So, thank you for listening, and I'll see you all next time. Bye-bye.